All right, guys. So our last little bit here is on counterexamples. All right, so a couple things about them. So to start, it says to prove a conjecture is true, it actually has to work 100% of the time. All right, so to prove it as true, it has to work 100% of the time. Infinite examples, all right, where it is always true, okay? But to prove it as false, you only need one counterexample, and that's why proving a conjecture as false is much easier than proving it as true, because you only need one example, all right, where it's false, okay? But for a counterexample to be valid, all right, the first part, all right, of the conjecture has to remain true, while the second part is the one that we're proving as false. And I'll explain that in a second, okay? So let's actually just start looking at examples, and I think it'll make more sense, all right? So here we go. It says, determine if the conjecture is true or false based on the given information. Give a counterexample for any false statement. All right, explain if the conjecture is true. So if we start with the first one, it says, if two angles are supplementary, then they are a linear pair. So we have to decide, is this conjecture a true or false statement? So this is going to be a false statement, all right? And we've talked about this in chapter 1, where can we find an example where two angles are supplementary, but they are not a linear pair? All right, so we have to remain with this part as true in our example, but this is what we're trying to prove as false, all right, that they're a linear pair. And of course we can do that, all right? We can have this example right here where we have this angle that's 100 degrees. And then this angle right here that is 80 degrees. Are those two angles supplementary? They are, because they add up to 180 degrees, but are they a linear pair? And they're not, because they're not adjacent, all right? So that's a good counterexample, all right? So again, this first part is true. These are supplementary, but it's the second part that we're proving is false. Let's try the next one, all right? Points A, B, C, and D are collinear, which means that they're on the same line, all right? The conjecture is that the length of AB plus the length of BC plus the length of CD is equal to the full length of AD, right? So if we look at this line, and let's put 4 points along that line. 1, 2, 3, 4, okay? And does it have to go in the order of A, B, C, and D? All right, if it did, this would be true. But what we can do is we can flip-flop one of those. All right, what if I went A, whoopsie, that's kind of bold. All right, A, C, B, and D. All right, would this be a true statement? That if I added, all right, this length of AB, all right, with this length of BC, and then this full length again of CD, would that equal the full length of AD? And that's no, because you're going to be adding that in between segment of BC 3 times, right? So this is a good counterexample, okay? You could have another one too. You could flip-flop, all right, B and D, and that would be a good counterexample as well, okay? There's many counterexamples for this. Let's try 3. If the name of a month starts with a J, it is a summer month, all right? And this is false, all right? January. January starts with a J, all right? But it's a winter month, okay? All right, number 4, if two angles are congruent, then they have to be vertical. This is false, all right? We can find two angles that are congruent that are not vertical, all right? What if I just bisected this angle right here? So let's say I have this angle and I'm just bisecting it, okay? And I'm looking at these two angles right here. Are those two angles congruent? They are, so we're keeping that first part true, but are they vertical? And they're not, all right? So that's a good counterexample. All right, so I'm only going to do 2 more, all right? And I'm going to do number 5, where it says you can connect any 3 points to make a triangle. And so sometimes when students are in class, you know, I always give them this on their own to be creative with, all right? And that's exactly what we're going to do here. So if I would make this line, and then I have these 3 points, 1, 2, 3. All right, can I make a triangle from those points? And the answer of that is no, I can't. All right. So then the last one that I want to go over is number 7. Any 3 points are coplanar. And can you draw 3 points that are not coplanar? And the answer to this is no, all right? You can't. So this is actually a true statement. And we know it's a true statement because of the definition of coplanar. And the definition of coplanar points is that any 3 points are coplanar, so that has to be true. All right. So, ladies and gentlemen, we'll go over these theorems, all right, as an entire group in class on Thursday, all right, because they're really important theorems. So I want to make sure that we hit them pretty hard, all right, in class. So that's it. Hopefully that made sense. If not, we'll go over this again tomorrow. Let me know if you have questions. And again, we will go over these notes, these 2 definitions in class on Thursday.